All right, this is video number 2 for section 6.6, and in this video we're going to look at solving some different polynomial equations by using the factoring techniques that we looked at in the previous video, okay? So get right into an example here. I want to solve 8x cubed equals 27, okay? And I'm just going to begin by subtracting the 27 over so that this equation becomes set equal to 0. Okay. And by subtracting that 27 over, what I'm noticing is it creates a difference of two perfect cubes, right? So I can now factor that using that pattern that we learned yesterday. It's going to factor to a binomial times a trinomial. The binomial would be 2x minus 3, where 2x is the cube root of 8x cubed and 3 is the cube root of 27, okay? Then the trinomial, its first term would be 4x squared, which is just the square of 2x, then plus 6x, which is the product of 2x and 3, and then plus 9, which is simply the square of 3, all right? And now that we're completely factored, we just use the zero product property to solve the equation. We set each factor equal to 0. All right, so 2x minus 3 equaling 0, that's very simple to solve. So my first solution for this equation is x equals 3 halves, okay? The quadratic equation, however, that is a little bit more challenging to solve because it's not further factorable. So my options to solve this now are either completing the square or quadratic formula. And I think quadratic formula is the best approach here. So x is going to equal the negative of b plus or minus square root b squared minus 4 times my a times my c value all over 2 times my a value, right? Now we simplify. That's going to be negative 6 plus or minus square root of 36 minus 144 all over 8. 36 minus 144 is negative 108. Okay, let's see, 108 is not a perfect square, but let's see if we can pull anything out. 108 is the product of 54 and 2. 54 is 6 and 9. 6 is 2 and 3. 3 and 3. All right, so there's 3s that can be pulled out. And then you also have a pair of 2s, so I can technically pull a 6 out here, as well as I, since this is the square root of a negative number. So this becomes negative 6 plus or minus 6i radical 3 all over 8. And then you can reduce a 2 from the 6i and the 8. So that gives me negative 3 plus or minus 3i radical 3 all over 4. Right, so technically those are two solutions that are both complex, okay? And I want you to notice that altogether there are 3 solutions here, 3 answers, and that is not a coincidence. If you go back and you look at the original equation, see how the highest power on x was 3, okay? Second example, here the equation's already set equal to 0, so we have this trinomial that's following a quadratic pattern, all right? So we looked at how to factor these in the last video as well, right? If it's a quadratic pattern, then to factor it would end up factoring to 2 binomials. They'd both have to begin with x squared, and I would need two numbers that multiply to negative 45, outside and inside parts of FOIL have to add to negative 4x squared. So that's going to be from negative 9 and a positive 5. Okay. And then recognize x squared minus 9, that's factorable as a difference of perfect squares to x plus 3, x minus 3. But x squared plus 5 doesn't factor further, okay? So now that you're completely factored, take factor, set equal to 0 by the zero product property, and solve for x. So we're going to get x to equal negative 3 as one solution, x to equal 3 as a second solution, and then over here we can subtract 5, then square root both sides. X would then equal plus or minus I radical 5. So those final two solutions are imaginary, but once again, notice how many total solutions there are to this equation. There are 4 solutions, which matches the highest power on this equation, or the degree of the equation. Okay. Final example here. All right, so I'm going to, let's move everything over to one side. Get it set equal to 0 again. 4x cubed minus 8x squared subtracted by x and added with 2 is equal to 0. All right, so think about factoring techniques that could work now. You have 4 terms. There is no common factor between all 4 terms. So this is perfect for grouping. Okay. The first 2 terms of 4x cubed and negative 8x squared, they have a 4x squared in common. If I factor that out, I would be left with x minus 2. And then negative x plus 2, really the only thing they have in common that I'll factor out is minus 1. And that would leave me with x minus 2 as well. All right, so since these are identical, that leads me to the following factors: 4x squared minus 1, as well as x minus 2. Recognize 4x squared minus 1 is a difference of perfect squares, so that factors to 2x plus 1 and 2x minus 1, and then carry down the x minus 2. Okay. Set each factor now equal to 0. So x could equal negative 1/2, x could equal 1/2, or x could equal 2. 3 total solutions to once again match the degree or highest power of the original equation. Okay.